A really nice feature of xStream Standalone or View Infinite is the ability to see the atmosphere within the OpenGL. And when using xStream within Cinema, we don't have that option. And it can be really nice to have that within the scene. So I'm going to show you how you can create an OpenGL preview of the atmosphere. And this technique can also be used to generate HDRI images if you want to render the scene out that way. So I just have an atmosphere with two cloud layers, and I do want to make a note that I have noticed a problem at the moment for the last couple of versions of xStream, and that is when you load clouds into the atmosphere editor through xStream, they do tend to have different material settings than the presets would normally have. For instance, the Spectral 2 low altitude cloud collection I created, you can see the altitude listed, the height of the cloud layer, and density, and just included that information within the description. But when you load this in as a layer, that information is not stored and not remembered within xStream, and it basically resets the values. So you may need to just copy that information over, or what you can do is basically use the standalone version, maybe not even tied into a scene directly with xStream, just opening it up separately and adding the cloud layers in that way. And it's a little easier to do that anyway because you get an instant preview without having to worry about the proxies. I just wanted to make a note about that in case you are using the collection or you've designed your own clouds. Just keep that in mind. You might have to go outside of xStream, going into the standalone, so get out of Cinema in order to get those clouds to show up correctly. And there are typically changes with the internal unit, but the internal unit I have set is exactly the same as the collection was designed in, so I know that that is not the problem. So we just have two cloud layers. What I want to do is go ahead and just cancel that out so I don't make any changes. And the best way to do this is through the standalone version to render out the scene. With recent updates to xStream 7.5 and I believe 7.4, the Export Sky option, go to File and Export Sky. This has always been a one-core rendering feature. So if you've got a 4 CPU system or 8 CPU, it's only going to use one to render this export. And with the newest version, this was supposed to use all your available cores, although at the moment it appears to still be using one core. But there is a new option and really a huge improvement that allows us to just bypass that altogether. So I'm going to open in standalone view, and now we can see our cloud showing up. But an improvement has been made to the panoramic and spherical renders with 7.5. And version 7.4 should work the same. Basically what we can do is just, in the render options, turn on panoramic view and spherical render. Previously, this wouldn't be usable for spherical mapping on an object to use for HDRI or any sort of previewing. But the feature has been reworked and now will properly generate a spherical map. So I'm just going to set this to a lower setting just for this preview so you can take a look. And I've already rendered out this sky. But before I go ahead and render, there is one thing. That's basically the placement of the camera does need to be manipulated for this to work correctly. So what I've found works well for my OpenGL, because I have noticed there is a slight difference between the render. So if we were to take the image that we're mapping to the sphere and render it, it's going to be slightly off from the OpenGL, and that could be a driver for my video card that is causing that little bit of an offset. I'm going to use those values that I found worked, because it could also be a cinema OpenGL problem. More than likely, it's just my video cards. So anywhere close to this range should work for you. If not, you can just manually adjust the object. Basically, setting the orientation of the camera to a pitch of 90, roll at 0, and the yaw, Z, to 214.5. And once this is set, you shouldn't have to manipulate the object this is attached to in order to get it to match the existing scene. So if I was to render this right now, you can start to see the stretching up at the top, which shows that it is a spherical render. Previously, that was based on manipulating the camera focal and not actually creating a spherical type render. So now what you can do is export this image. You could use the EXR format, or you could use the HDR. That's if you want to use this for HDRI lighting. If you're just going to be using it for a preview, then it's best just to kind of use a crappier format, something like a JPEG. If you want to improve the resolution, still have a decent quality, you could also set this to PNG. PNG files work really well. So I've already got this saved out, and I just ran a Photoshop filter to remove noise since I did just a preview render. We're going to hop back over to Cinema, and I am just going to close this out and not save, because I don't want to manipulate the camera position I currently have, and that way you can preserve what's in the scene. There's two different ways to apply that image to an object. One method is to just use a sphere and scale it up around the scene. But if you have access to the sky object, that will work best. So if you're using a sphere and you don't have the sky object, just create a sphere, scale it up larger than the scene. But I'm going to show you the sky object, and what we're going to do is create a material, and I've already gone ahead and created this material. We'll go ahead and create a new one. Just going to call it OpenGL Sky. And if we go to the material editor, all we need is the luminance channel. Check on luminance, and then load in the image. And I just have this called Sky 2. And I'm going to create a copy. And now I'm going to turn off the specular channel. And in order to get this to show up best that it can within the OpenGL, I'm going to turn up the texture preview size. And this image is no larger than 2000 pixels, so 2048 by 2048 is more than enough. And we want to make sure that we're using the enhanced OpenGL. And now what I can do is drag this OpenGL sky onto the sky object. Now it is not matching at the moment. There is a modification we need to make because we are looking at it in reverse, and it needs to be inverted. So we can just going to find another area of the scene so that this shows up a little bit better. But we're modifying just clicking on that texture tag. And I'm going to create another little preview. Actually, make sure I turn off the sky object from the render. But this way we can see how it's going to match up. So before we make this change, we could just take a look at what we currently have, and we can see that it is in reverse. This side over here on the left should be facing the other direction. So we have this little bit coming over here in the render on the left, and that's this part up here. So we do need to reverse it. The easiest way to do that is just go to Tiles as part of the texture tag and hit -1 for the X. And once I switch that, we can now see it matching up really well to what's currently in the view. In this case, I don't think it's completely perfect. It may need to be adjusted slightly. So if you do need to make any modifications, you can just go to the sky object and then select the coordinates, and under heading you can just adjust that to get it to match up as best you can. It's really just a preview, so it doesn't need to be perfect, but if you are using it for HDRI, then you will want it to be as close as possible. Now, if we did want to use this for HDRI lighting, this is a really low quality render. I just did it very quickly. But we can still use it, and I can show you how we can set that up. If we go to the atmosphere editor, go to environment mapped, and I'm going to go ahead and turn these cloud layers off. They will be remembered if we go back to the spectral mode, but we're not going to be using that. We're going to environment mapping. I'm going to turn off the density for the fog and for the haze, because I don't want those in here. And under the effects tab, when using environment mapping, you can load in the image you want to use to show up as a background, and then also set up an illumination map, so what's going to be lighting if you want to separate those, and then also a reflection map if you want to have separate reflections. So we can just load in that image, and you can choose to map the ground plane, and that will apply the image to the ground. You see there's a little bit of curvature, and that's actually the shadow from the clouds on the ground plane. So that is a perfectly straight line, because we did have the pitch at 90. So those clouds will cast their shadows within the scene, and also using the image, because now we don't need to have the rest of the sky in there. So we're going to map the ground plane so that it matches up. And we could set this to radiosity mode, or GI, to really get the most out of this. And I'm just going to keep the rest of the settings the same for now. That should be more than enough. So now we have this set up, and the positioning of the atmosphere and that image might be a little off. You might need to offset it or reverse it, as we had to reverse it for the preview. Might need to do the same, although the coordinate systems should be similar. So we'll just take a look at a quick render, and since we have the radiosity mode on, might take a little bit longer. We'll go ahead and do full view because it went pretty quickly. And it does look like the image will need to be adjusted slightly. It's a little off, and definitely doesn't match the OpenGL preview that we have. So you can make adjustments if you want to. Go to the atmosphere editor, and you can use the map offset for both U and V to nudge it side to side, position it where you need to. But now we have a scene that is lit just by this image. So things can move and render a lot faster. If we load in, let's just grab a sphere object so that we can see how that's going to be lit. Go ahead and render that. And I want to note we still have the sunlight in the scene. So we're going to see a pretty harsh shadow. We don't have 100% light directly from the image. In order to do that, what we need to do is switch it to ambient light. So go to the atmosphere editor and switch light balance all the way to ambient. Once we do that, now the sunlight is no longer used, and it's just going to use the image itself to generate the lighting. And now we can see that showing up. I'm also going to just throw in a cinema object, and my scales right now are a little bit off. But that's all right. Now we'll take a look at scaling and matching that up in a different part of the training, because there are some important points to do with the different scales. So because there is no longer a light affecting cinema objects, all cinema objects are going to show up black. And that's a problem. If we take a look at the bottom, we do have the cinema object generating the correct radiosity, but the image itself and the diffuse of it is just black. There's no light affecting it. Well, let's take a look at what happens when we turn on global illumination. So go ahead and open the render options, select global illumination, and I'm going to set this to low end preview just so we get a fast render. So now we have light on the object, but in view we've lost that bit of shadow. Now in this case you could just use the floor object within Cinema, but we really do need to be able to use this feature, of course, with more complex scenes. This is obviously just a simple example, but chances are you're not going to be using xStream in Cinema to create such a simple scene. So let's take a look at a couple of options to correct this and get it to work properly. Let's start by just creating a material for this sphere, because right now it doesn't have a material. Just call it C4D sphere. You can drag it onto the material, or onto the object, and I'm going to go ahead and make the object editable, which shouldn't affect the outcome of the render. But I just want to get that taken care of now, just in case we do run into any problems like we did earlier with reflections. Okay, so first, there's one method, and that is basically to use the sky sampler instead of our other GI types. For this, though, we'll have to render our sky object. So what we need to do is add in a compositing tag and just turn off scene by camera. And that will also remove our OpenGL Preview. So I'm just going to create a small render. And now we can see the shadow's still there, and it's lit up a little bit better than it was, but we don't have a very good amount of depth. And the diffuse is still a little off. We've also lost the influence of the ground. So let's go ahead and use the floor object and just delete the ground plane. And basically this looks worse than it did before. So we've lost even more options here. And sometimes when objects are intersecting, we'll run into that problem. But for the most part, that back and forth radiosity and GI isn't really working directly. So what you can do is just take the most advantage of compositing as you can. And although xStream seems like an all-in-one solution always, you are going to run into problems, and compositing really helps fix all of those problems. Not that it makes the integration useless at that point, because you can take advantage of having everything all in the same scene and being able to use the gbuffers and multipasses to get that direct interaction between the two scenes. So that makes it extremely helpful. And I'm just going to do one last method here, because there are different methods for different scenes, and really depending on what's the more dominant object. I'm going to delete this floor object, and we're going to add in another ground plane. And we can see that's just called infinite plane. Drag that slightly under the objects. And we're going to switch back to the IR mode. Get rid of our compositing tag. Turn off the sky. And what I'm going to do is just create another sphere within view. Scale it up and kind of put it inside the other sphere. And once we render this, we're going to see that show up correctly. Now, you're not always going to have this option for every single scene. And that's going to present some problems, obviously. But it does open up possibilities for exporting cinema objects into view just for the purpose of generating the shadows and correct GI. If you do take a look at the render, you will notice that the ground isn't fully affecting the object, at least not as much as the view object. So if needed, you may also need to add an object into cinema to be the ground, or use a compositing tag on the infinite plane if the infinite plane is recognized. So there's just one last thing I want to show you, or really just kind of mention, since we are working with previews, created an OpenGL Sky. There's one object that will not show up within Cinema. At least it shows up as a null. And if you're not familiar with changing the look of null objects, then this can be helpful. Basically, it's the ventilators. If you're going to be using a ventilator, they will show up as a null object, which by default is the display dot. And you can't really tell what's going on. So if you select the ventilator, you can change its shape and what it's going to look like in the preview in the OpenGL, and change its scale. So that way you can get a good idea of what it's actually going to look like. and there's a lot of different shapes. You could also assign geometry to these as well, linking the positions to see it a little bit better. And you could use a display color to change that, say to green. So these are basically flat planes facing the camera that will always stay the same, kind of in a old video game style, with 2D plane characters always kind of facing you. And then every once in a while they'd change, but in this case they won't. So that can be helpful if you're not familiar with changing the look of a null object, just because the ventilators themselves are difficult to see. Another thing, especially for the directional ventilator, which really is more like a light in its shape, you might want to assign maybe a spotlight to it, and just make sure that that spotlight doesn't affect the scene. And that way you can find out what direction it's facing and know exactly what to do with it while you're working in view. Because otherwise, it's going to be difficult to tell exactly where your ventilators are at. So that's just kind of a little helpful display hint.